pass it, rather I have to declare it in exactly the same way. So let me go ahead and do UI. Let's go ahead and just copy paste. Let's go here. All right, let's go back into here. Paste that in here. UI alert view, did dismiss with button index. Put this here. All right, and just as a sanity check, we'll do the whole nslog thing again. So nslog at, nslog at here, save. All right, so let's now do this. Run, stop, run. And here we go. Very exciting. Let's open up the debugging window so we can see the amazing new feature. Go, and then thanks, and I screwed up. All right. What's that? Oh, yes. Perfect. Thank you. So another example that was not meant to be part of the discussion, but it's a good pedagogical trick. So what did I do wrong? So according to Tommy, the key actually is in, RJ. My apologies. So as RJ noticed, we've forgotten to inform this object, the UI alert object, to whom it should send this message once that button has been clicked. And indeed, when I first implemented this very long name method here, or rather called this very long name method, notice that for delegate, I said nil. But in fact, if I am implementing this response inside of myself, using UI alert view did dismiss with button index, I can't just say that there's a nil delegate, because then a message is going to get passed to nil, nothing's going to happen, case in point, per the demo. But if I instead want that message to be passed to me, I simply say self. And recall that self is like this in PHP or Java. So now let me go ahead and recompile, rerun this code, and now hopefully that message should get sent to me. I'll open the debugging window in the background, type my name, type go, all is well, and then thanks. And there, it's actually called this time. So how do I actually now do something that's more interesting? I can do self.textfield .text gets nil, and this will essentially clear the text field. So now if I rerun this application and I type in my name, then type go, and then thanks, notice, watch the name David, it has now disappeared. Very amazing. I'll make this available for download after class. Let's go ahead and take a 5-minute break. When we come back, we'll look at ATM and then project 2. All right, so we are back, and the teaser for Project 2 is this. For Project 2, you and your partner will be implementing a so-called utility application, which means it's an iOS application with two sides, a main side and then a flip side. And on the main side is where users will be able to play not quite Hangman, but rather Evil Hangman. Those of you unfamiliar with Hangman, it's a game where the computer picks a word from a dictionary, and then you have some number of guesses, letter by letter, to figure out what the computer is thinking of. It's an incredibly mind-numbing game once you are our age, or your age, sadly my age. But Evil Hangman is much more exciting. In fact, it's a great game to play with your roommates or have them play it, because in Evil Hangman, the computer cheats. Rather than committing to a pseudo-randomly chosen word at the beginning of the game, it instead chooses a length for a word, and then that's it. And then it looks at its dictionary of all possible words, thousands of words, and the user proceeds to guess a letter, like the letter E. What does the computer then do? It then scours its dictionary, eliminates all words that actually have the letter E in them, and says, nope, there are no E's in this word. So then you get a strike against you, and you have a finite number of strikes. And so then you, the human, get to play again, and you choose like an A. And the computer looks through its list of non-E words, further eliminates any words that don't have E's, and eliminates words that have A's, so as to shrink the list of all possible words even smaller, so that it can then say to you, nope, no A's in this word either. Now, mind you, the computer still doesn't know what that word is going to be. It's constantly trying to evade your guesses, and at some point, after some number of guesses, the computer's probably going to have to make a commitment, because you're going to say the letter N, and just by chance, all the words that it has left in its data bank have the letter N in them. So it has to choose which of those words, or rather, what location of N to reveal. So it looks through its list of words, that have, all of which unfortunately have N, but N might be here, or here, or here. So the computer has to decide, fine, N will be here, and then further whittles its list of words down to only those words that have N in that location, but no A's and no E's. Now, meanwhile, the the clock is ticking and you're guessing wrong, guessing wrong, guessing wrong. So odds are you, the human, are going to lose. And indeed, when you actually see this game played and watch your roommates' reactions, the word almost always ends up being something ridiculously obvious, like puppy. It's just such that you never actually guessed any letters that were in such an obvious word like puppy. And that's simply because the computer is evading, evading, evading. So it's a great way of making your roommates feel really stupid when playing your CS164 project. So that's the game you're going to implement. We'll talk a bit more technically about how you'll go about wiring it up, but realize that there'll be a walkthrough for the project spec this Wednesday. So do realize that even though project 1 is due this Friday, the proposal for 2, and recall that the proposal means read the spec, do just the Bitbucket stuff, and decide between you and your partner who's going to do what for this project, because the design document and style guide will be due next week. All right, so let's turn our attention then back to Xcode and take some steps toward doing something like that. So recall that we left off last time with this ATM, which I didn't want to do before that more fun app just now, because there's a lot more going on. But it's a lot of copy-paste, really, recall, because we have a lot of buttons, all of which do effectively the same thing. Send a message to the view controller indicating what button was pressed. But let's see if we can't tease this apart now, because realize, especially with Objective-C, which is new to most people, your partner is going to be writing some code, you're going to be writing some code, and he or she is also going to be doing stuff with nib files, potentially. So being able to understand what someone else has done, whether it's me or Tommy, the TFs, or your partner, is actually quite important. So do keep in mind the various tricks and the clicking and the right-clicking that will reveal to you exactly what is going on in an iOS application. So recall that this is where we left off 2 weeks ago with the ATM. And recall that this example introduced a little more than just a view controller and the app delegate. I manually created 2 files called account.h and account.m. Because much like our discussions weeks ago of MVC, I wanted an M in this application, a model that represented a user's account balance. Now, I could just have a global variable or some kind of instance variable inside of my view controller, but that didn't feel quite right, and it shouldn't feel right to you. The view controller should be about talking to model, talking to view, but not necessarily storing a whole lot of state itself, at least not state that could be represented with an entity like an account. So recall that I declared a very simple class called account. And in this, I simply said that account descends from NSObject. It has no instance variables per se. So in fact, I didn't necessarily need the curly braces. That too is valid syntax. But it will have a property. So in fact, it will have an instance variable. It's just going to get automatically synthesized for me. And I decided that an account, in the bank sense, has a balance. And it's going to be unsigned because I don't care about going negative. And I want it to be a 64-bit number. So I said long, long. And then I specified that it's a property, non-atomic, and a sign. Again, for now, a sign we will almost always use with primitives like longs, whereas we used strong earlier with pointers. So we'll get back to that in a week or two as to why the distinction. For now, we'll use a sign. So inside of account, there wasn't all that much going on. But I did have an init method. So inside of this init method, I declared that a balance by default should be 0. Why all of this if and whatnot? So this is just convention. Anytime you write your own init method, you should generally call your parent class's init method, as implied by self gets super init, just in case someone above you needs to do some work on this object first, namely the NSObject implementation. Then you can do whatever you want. Then you should return self. So if and when you write your own init methods, they should almost follow this paradigm where you implement the stuff between the curly braces. And you can also have custom init methods if you actually wanted to take in arguments like this. But for now, it's just init. And notice that I don't actually have getters or setters implemented here, even though I'm presumably going to want to get and set a user's account balance. So why is this class so simply implemented? Where is my getter and setter? Yeah, so in synthesize, I'm going to get that for automatically. So this, recall, synthesizes that property, but also creates the getter and setter that will allow me to access a property called balance. So in other words, as a result of that line, I can either access a user's balance with a, let's call this an A object. If I've done, let's say, account star A gets account alloc. So that has given me one of those things. And then I'm going to call init as well. OK, so this first line creates a pointer of type account called A. This side allocates it. This calls the init method, and done. Now I have an object called A in memory. If I subsequently want to access the balance, I could either do this, get A, and then pass it the message balance, because this is the name of the getter that is automatically synthesized for me. So I could do long, and I should do unsigned, so pardon the mess here. Unsigned long X gets this. So that would now be valid syntax because I got balance for free thanks to synthesis. I could also say A arrow what? Arrow notation is used in a structure or an object to get at its instance variable. So what's the instance variable here called? Underscore balance. So I could do this. Don't do this, but you could do this. Or more simply, I could just call what? A.balance, which is the preferred way these days. Even though you're incurring some slight function overhead, just as you are here, this is the habit to get into according to convention and best practice. But all of these work, and the fact that this works with the underscore is because of the highlighted line there. If I did not have that highlighted line, you would then get rid of this here. And now it's just a little less obvious, though. Is balance the getter or is it the instance variable? It's more clear with the underscore as to which is which. Yeah, Carl. This, yes, is identical to this. It's just this is syntactic sugar. It's just easier and cleaner to read and write than that. Perfect. OK, so thus did we introduce in this ATM a model. Similarly, in Project 2, will you need to implement one or more models to represent, in the case of Project 2, a strategy. And the project spec and the walkthrough will walk you through this. You're going to have to implement for Evil Hangman, not just the old school strategy for playing Hangman, where you actually pick a word at the beginning and then you stick to it. You're going to have to implement an alternative strategy, the evil strategy, and both of those will be model classes that are presumably going to have methods that say things like, that have methods that you call when you want to find out what the response should be to the user. User guesses n, you pass in n to this model's method, it's got to return yes or no, is it there, or something along those lines. But again, more on the spec and more on the walkthrough as to the particulars. All right, so this was the ATM. Let's take a quick look at the app delegate. There is nothing interesting here. This is essentially the template code, but I added some comments and cleaned up the white space. In appdelegate.m, similarly, there's nothing new here. I simply cleaned up the white space. I deleted all of the stubs that I wasn't going to use anyway for backgrounding and all of that. And this, notice, is identical to what we talked through earlier in appdelegate. So there's no magic there. In viewcontroller.h, there is some stuff going on. So this is stuff that we did write 2 weeks ago. So let's reverse engineer how this code actually works. So assume it was, say, written by your partner. So we apparently have a few IB actions. An IB action, again, is a method that's invoked as a result of some user interface interaction. A button press, a pinch, a swipe, something like that. IB action actually is not some new return value. This is actually a little preprocessor trick that Apple did. So notice these are instance methods. But IB action is not a return type. In fact, IB action is a type def for, if you think back to your C days, void. So literally, there is just a line of code that makes IB action a synonym for void. So this means the compiler doesn't know or care what IB action is. Rather, what Xcode is doing is Xcode itself is skimming any code that you write. Anytime it sees an IB action, it makes a mental note to itself to make sure that the name of that method appears when you click, drag, and let go. This little gray drop-down menu of possible methods that you could invoke is simply there because of those little visual hints that you put in your code. So it's similar to type hinting in some languages. This is just a GUI trick, and the compiler doesn't even know what's going on ultimately. All right, so this is viewcontroller.h. Let me put that back to IB action. Otherwise, it would not appear in that dropdown, which would make it hard to wire up. Show, meanwhile, is just a method that I wrote to clean up my own code. So I'll wave my hand at that for now. But now let's take a look at IB actions and these properties. So I need inside of my view controller a pointer to an account. So again, view controller is the C in MVC. This is the controller. I have a pointer to a model of type account. So here is one of those arrows from the diagram we keep putting up when we talk about MVC. Amount, meanwhile, is also apparently redundantly here so that I have a running tally of what the user is trying to deposit in this ATM. I could actually have another model and store that, but I decided to keep it a little simple because I just needed one simple little number. But we could factor that out too. Now here, balance label, deposit label, these are apparently both pointers to UI labels. This is my code mechanism for talking to the GUI. So I can actually read the value of and even change the value of those two labels. And IB outlet, take a guess. What does the presence of the keyword IB outlet now do apparently?